Okay, the next model is the opposite of what we saw in the previous one, which is complementary product. So if you sell a product that generates demand for additional products. But here we are talking about products that are either or. So either you buy this, if you buy this, then you're not going to buy the other one. But if you buy the other one, then you're not going to buy this one. So alternative products. And how do you price the two products that you're selling, which are alternative products, such that the total profit is maximized? And this example is illustrated with a power company, and we have power that is sold at one price during the peak period and a different price during off-peak period. And we want to price them in such a way that you're able to meet the demand, and you may have capacity constraints also in this case, because you may have a built-in capacity that you cannot exceed during the peak periods. So here is an example that is given. So D sub P would be peak period demand for power, and D sub 0 or D sub O will be off peak period demand. And similarly, P sub P and P sub O are the two prices that we have to set. P sub P is peak period price, P sub O is off peak period price per unit, per kilowatt hour of power. And so here we have the two functions, and you see that the demand has a negative coefficient for price of the same time frame. So peak period demand has a negative slope with peak period price, because if the peak period price goes up, the demand is going to go down during peak period. But it has a positive slope with respect to off-peak period price. Because if off-peak period price goes up, then some of that demand would come to peak period. The opposite here, during off-peak period demand, would be if peak period price goes up, then the demand will shift from peak period to off-peak period. So you have a positive slope there. And if off-peak period price goes up, of course the demand will go down. So now how do you set this up? So we'll go to the Excel file now. Okay, we have some inputs here. Okay, so these are given. So input values. Now we have cost per kilowatt hour capacity. So we want to build the power plant in such a way that the cost is taken into account. So the more you build, the more cost you're going to have for building that capacity. So decision variables are, now you have to set two prices, peak load price and off peak load price. So there are two prices. And now we have capacity. So capacity will be, let's give a name. Okay. Now capacity is another decision variable that we have to have. Let's give a name here. Okay, now we set up the demand. So demand is, okay, so P sub constant, okay, plus peak price so we'll multiply that with the peak load price, okay, plus off-peak price coefficient times the off-peak price. So that's the demand for peak period. Off-peak will be, so again we use these coefficients, constant plus, this is the peak period coefficient times peak period price, plus off-peak period coefficient times off-peak period price. So make sure that you set the constants up properly. Okay. Now these are the demands, and capacity is of course that, and we want to make sure that the demand doesn't exceed capacity. So we have a less than or equal to constraint for the demand. Okay. Now monetary summary. What is the revenue? Revenue is the sum product of the demand with the price. Okay, let's give names. So revenue will be some product of demand with price. And cost of capacity will be how much capacity we're going to build times cost of capacity per kilowatt hour. So we take the revenue minus cost of capacity, and that's our profit, which we want to maximize. So go to solver, profit, maximize. We have the prices and the capacity. Okay, now we need to add. The constraint will be demand less than or equal to capacity. So let's go to options. GRG nonlinear, uncheck this, use multi-start, and solve. Okay, now we'll run a solver table for cost of capacity. Okay. Go from 5 to 15 in increments of 1. And then we'll see what the prices will be, comma, let's control click the capacity that we will build, comma, control click the profit. So here we are. As the cost of capacity increases, okay, the capacity decreases that we're going to build, and here are the charts. As cost of capacity increases, the capacity we're going to build goes down, and the profit goes down as well.